portion of section 5.3, focusing on a series of very important trigonometric relationships. And we're going to start with a document that I call 5.3 Foundations. Please hold on to this. It's a very, very useful document. And we're going to refer to it over and over again. It's another variation of the bow tie diagram that we saw back in our circle unit when we proved the equation of a circle. But here's how this document is structured. I'm going to start with 4 arcs: red, black, green, blue. You'll notice that they create 4 different angles in 4 different quadrants. They have 4 different terminal points, 4 radiuses of a circle: red, black, green, blue. And they all have terminal points. And what you'll notice on this is that there's a great deal of symmetry about these 4 terminal points. X, Y, positive X, positive Y. Symmetry, Y coordinate the same, the X coordinate's now negative. My green terminal point, both coordinates negative, both still having the values of X, Y. And in the 4th quadrant, my blue terminal point, X positive, Y negative, X negative, Y. If I go to these 4 terminal points and connect to the x-axis, either going up or going down, depending on which of these 4 points, I create a right triangle. And there's some important pieces about these right triangles. Each one of them are part of the bow tie. And most importantly, all 4 of these triangles are identical. They share the same horizontal length, so to speak, which is X, and they have the same altitude, the same height, Y, and they all have the same hypotenuse value, R, the radius of this superimposed circle. And so it's true then that these 4 different triangles and this nice little angle inside the bow tie, which we'll talk about a little bit more, they all share the same trigonometric ratios. So these arcs create angles, all of which have the same structure triangle-wise, 4 identical triangles, and these little inside angles always have the same ratios. The trigonometric numbers and values are all going to be the same. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. The key extra piece to realize is the following. For the angles that we create, they all share these following important ratios. The sine of the angle that creates these right triangles is the y coordinate divided by r, the hypotenuse, y over r. The cosine is nothing more than the x coordinate over r. The tangent is nothing more than y over x. And what we're going to find is, based on which of these 4 bow ties you're in, which 4 angles were responsible for creating you, these ratios are going to stay the same, but there's going to be a positional aspect associated. For instance, the angle, the arc in black that creates this angle in the 2nd quadrant, it's going to have its x coordinate be treated as a negative number, its y coordinate as a positive number. So when we start doing the trigonometric ratios, y over r is going to be a positive number. The sine of that black angle is going to be positive. The cosine is going to be what? Hey, our x coordinate happens to be negative. Negative x over r. And our tangent is going to be y over negative x. We're going to find that the tangent and cosine will both be negatives for this angle associated with that black arc. The sine is going to be positive. Again, these are the key ratios: sine of theta, y over r, cosine theta, x over r, tangent theta, y over x, and we're going to consider where our angle is located, where our terminal point is located, and therefore whether our y or x values are going to be treated as positive or negative. The fraction stays the same in all these 4 angle instances. We just might have to put a negative sign in front of some of our ratios. What else is true? X squared plus y squared equals r squared. Pythagorean theorem comes into play. So if you want, and I'm going to save this, and I'm not going to mark this up since I'm going to use this so much, that little height is y. that length is x. This little in blue, that would be y. Length again, x. So in each of these triangles, we have what? A horizontal length of x, a vertical length of y. X squared plus y squared equals r squared. R is nothing more than what? The square root of x squared plus y squared. Know these relationships, understand them, and you're going to be in great shape for this unit. Now, we're going to find we can make right triangles for any angle. The only ones that we can't are going to be the ones on the poles. We'll talk about that a little bit later. But every angle that we have between 0 and 360 and 0 and 2 pi, we can build some type of right triangle structure pretty much. Again, with just those couple of exceptions. And we'll be able to compute their trigonometric values. And if we remember our coterminal concepts, what we're going to find is angles that are greater than 0 to 360, greater than 0 to 2 pi, their coterminal brethren can be found to have the same trigonometric ratios. So 490 degrees is the same as, coterminal standpoint, 130 degrees. The trigonometric ratios for 490 degrees are exactly the same as the trig ratios for 130 degrees. So if you work through all these coterminals, what you can do is go ahead, take these different angle values, make them coterminal, put them between 0 and 360, or down here, 0 and 2 pi, just by working your coterminal formulas in radians, plus or minus 2 pi, degrees, plus or minus 360. What's the key implication? Memorize this little chart. It's just another version, it's the book's version of this chart. And what do we know? For any terminal point out here, x, y, x might be positive, might be negative. All depends again on where that terminal point is located. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Here are all our trigonometric ratios. Sine, y over r. Cosine, x over r. Tangent, y over x. The three reciprocals. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent. And look how the fractions have flipped in those pieces. Last piece, these ratios, again, consider for each one, is x positive or negative? And you might have to adjust the sign from either positive to negative, so on and so forth. Adjust the sign, the S-I-G-N is what we're talking about there. So we're going to work through some problems. The first problem says, find the value of the 6 trigonometric functions given that the point negative 5, 5 is on the terminal side of angle theta in standard position. Well, negative 5, 5 is here. Negative 5, 5. By the way, there's angle theta that gets us here. I can build a right triangle, just connect right to the x-axis. And on this triangle, I can notice the following. Well, oops, excuse me, as I knock my camera over. My x-coordinate is negative 5. My y-coordinate is positive 5. I'm going to go ahead and label the triangle, and I'm going to actually reflect the fact, even though this doesn't have a length of negative 5, I'm going to handle it from a positional standpoint and mark a negative 5 here for my x-coordinate and a positive 5 there. The last piece for me to do is to figure out the value of r. Well, a couple ways we can do that, but the simple is realize, oh man, I must have a 45, 45, 90 triangle. That must be 5 root 2. Worst case, I could do the following, 5 squared plus negative 5 squared, and take the square root of that. 25 plus 25, I'd be taking the square root of 50, which square root of 25, square root of 2. There's our good old 5 square root of 2. So I know x, negative 5, y, 5, r, 5 root 2. Can I do the trig functions? You betcha. Sine theta, cosine theta, tan theta. Sine, what do I work with? Y over r, 5 over 5 root 2. We'll clean up a little bit later. Cosine, negative 5 over 5 root 2. Tangent, y over x, 5 over negative 5, equal negative 1. Cotangent, what do I do? Well, just flip. Well, if you flip negative 1, you still get negative 1. Cosine, secant is its reciprocal. 5 root 2 over negative 5 when I flip. 5 over negative 5 becomes negative 1. My secant is going to be equal to negative square root of 2. Sine, reciprocal, cosecant theta, 5 root 2 over 5 equals positive square root of 2. And my last piece of work would just be to do what? My precalculus cleanups, can't leave a square root in the denominator. This 5 over 5 becomes a 1, so this is a 1 over root 2. This is a negative 1 over root 2. And if I rationalize, just to get to my last piece, 1 over square root of 2, multiply top and bottom by square root of 2, I'll wind up with square root of 2 over 2 for my sine, and negative square root of 2 over 2 for my cosine. So a little bit of extra work was involved here. You can see all the pieces. Freeze the video if you need to. Watch the different steps here. But again, bottom line, do what? Get your terminal point, build your triangle, solve for the missing piece, in this case the hypotenuse, make marks of your x value, your y value, determine whether or not you need to have them marked as negative depending on where you are, calculate your hypotenuse, and you're good to go. One extra piece, your hypotenuse is always, always, always going to be positive in these problems. Tuck that away, remember it. New problem. The terminal angle passes through the point negative 3, negative 1. Negative 3, negative 1 is in quadrant 1, 2, 3, where both of them are negative. I'll draw over here. I know that what? X equals negative 3, y equals negative 1. I'm going to go ahead and label my triangle. This is the angle that got us to this terminal point at negative 3, negative 1. Connect to the x-axis with my right triangle. This length, negative 3. This value, negative 1. Find the value of r. Negative 3 squared plus negative 1 squared. And take the square root of that. I'm going to have what? 9 plus 1. R equals the square root of 10. So, if I work my way through this, what am I going to have? My sine will equal negative 1 over the square root of 10. My cosine will equal negative 3 over the square root of 10. My tangent will be negative 1 over negative 3 equals 1/3. Handle the reciprocals real quick. Cotangent is going to be 3. Cosine, square root of 10 over negative 3. Negative square root of 10 over 3. That's what my cosine is. My secant is negative square root of 10 over 3. My cosecant, flip negative 1 over square root of 10. That becomes negative square root of 10. Again, remember, clean up your denominators that have a radical in it. Negative 1 over square root of 10 becomes negative square root of 10 over 10. Negative 3 over square root of 10 becomes negative 3 square root of 10 over 10. And this problem is done. Now in class, I had you work through problems of this nature. I gave you some angles. Let me just repeat them real quick. I'm not going to do it here, but I'll just have you set yourselves up. I asked you to compute the sine of 57 degrees. I asked you to do the sine of 123, the sine of 237, and I'll move this up so you can see it, all in degrees, and then the sine of 303 degrees. And when you did it, you notice that you got the same decimal value each time, except in a couple cases, the answer was negative. That turned out to be 237 and 303, those two angles. And it turns out that those two angles are located in quadrants 3 and 4, where the y coordinate happens to be negative. The sign is what? Y over r. So when y happens to be negative, you're going to get a negative number for your sign. Quadrants 3, 4. I asked you to do these same calculations for the cosine function with those same angles, and you came back and you told me that you got negative answers in quad for answer with the 123 and the 237 degree angle. Why? Because the x coordinate for those two angles is both negative. The cosine is what? The x coordinate divided by r. Negative x coordinate will produce a negative cosine. And the bottom line is this led us into the following relationship that you see here as a mnemonic. To evaluate trigonometric functions, understanding the following key. In quadrant 1, x and y are both positive. So all the trigonometric ratios are always going to have positive results. In quadrant 2, x is negative, y is positive. What's that mean? That means that the sine is going to be positive, but the cosine and tangent are going to be negative. In quadrant 3, x and y are both negative. And the only ratio of the, what I like to call the big three, only y over x is going to produce a positive number in quadrant 3. In quadrant 4, x is positive, y is negative. Whoops, y negative, excuse me. What happens here in quadrant 4? Your cosine, which happens to do what? Be associated with the x coordinate, is going to be positive, but your sine and tangent will be negative. And this leads into this nice little quadrant-based document that you have. All STC, ASTC. This is telling you which of the big three trig functions, sine, cosine, and tangent, are going to be positive for the associated quadrant. In quadrant 1, you see the A highlighted. That means all trig functions, sine, cosine, tangent, are always going to be positive. In quadrant 2, you just see an S. The sine function will be positive. Cosine and tangent will be negative. Quadrant 3, tangent will be positive, sine and cosine negative. Quadrant 4, cosine will be positive, tangent and sine shall be negative. How's another nice way you can remember this? There's a mnemonic. All students take calculus. All students take calculus. Quadrant 1, all positive. Quadrant 2, sine positive. Quadrant 3, tangent positive. Quadrant 4, cosine positive. So we're going to work through this last batch of problems now using these general purpose concepts. These problems are going to give you a couple conditions. And you're going to use these couple conditions in a process of elimination to identify what quadrant your angle is in. And then you're going to repeat what you did in problems 1 and 2 above. Let's look at this. Cotangent of theta equals 1/4, and your sine is negative. Find the values of the 5 trig functions. We have cotangent, so I'll put it over here. What do we know? Well, in cotangent to be positive, also says that tangent must equal, in this case, 4. It has to be positive as well. Where is the tangent positive? Quadrant 1, all. Quadrant 3, tangent. So this tells us for the first condition, our angle must be either in quadrant 1 or quadrant 3. The sine, we want it to be negative. Well, we know that sine is positive in quadrant 1. It's positive in quadrant 2. It's negative in quadrants 3 and quadrants 4. So this is a Q3, Q4. I have to fit what? My angle has to match both these characteristics. What's that telling me? I better be in quadrant 3 for this example. Now, what else do I know? Well, I'll just go ahead and draw my terminal point for my angle. I know that the cotangent is 1/4. Cotangent is x over y. I know I'm in quadrant 3, so my x and y values better be negative. That's telling me that x equals -1 and that y equals -4. That's the only way. Quadrant 3, both x and y have to be negative. My fraction of x over y has to be positive. I have to have a negative over a negative. X equals -1, y equals -4. I've built my triangle. There's my angle that did all this good stuff. What do I need to do next? I need to figure out the hypotenuse. -4 squared plus -1 squared. Square root of that, oops, excuse me, there we go. Square root of 17. Do I have a great triangle to work with? I sure do. I know what x is, I know what y is. I know that r is the square root of 17. Cotangent is equal to 1/4. I knew that already. Tangent is equal to, I'll go in a kind of a different order this time. Well, it would have been what? Y over x, -4 over -1, or 4. But we knew that already, no problem. Let's go ahead and work our other big 2. Kind of working this in a different order than usual. The sine is what? Y over r, -4 over the square root of 17. Cosine, x over r, -1 over the square root of 17. We'll come back and we'll rationalize in a second. Let's go over here. Cosecant, negative square root of 17 over 4. Secant, negative square root of 17. Rationalize real quick. This becomes what? Negative root 17 over 17. This becomes -4 root 17 over 17. I have 5 nice answers to complement my original cotangent of 1/4. All right, one more problem to work our way through. This is going to be slightly different. Cosine greater than 0. Cosine is what? It's x over r. Cosine to be positive means my x coordinate better be positive. Quadrant 1, quadrant 4. My sine is 5/13. Well, that's a positive number. Sine is positive in quadrants 1, quadrant 2. I need to find the overlap. I need to be in quadrant 1. I know that the sine of theta equals 5/13. So by the way, hey, I already have the cosecant as 13 over 5. That's kind of a freebie if I think about it. Let's build the rest of my scorecard. Cosine theta, tan theta, secant theta, cotangent theta. Let's finish up. I know that the sine is 5/13. Sine is what? Y over r. I know I'm in quadrant 1. What do I know? Y over r. Well, y better be 5. R is 13. I need to find my x value. Pythagorean theorem says what? 13 squared equals, call that x squared plus 5 squared. Sorry, let me just move my camera again. Apologize for that. 169 equals x squared plus 25. X squared, 169 minus 25, 144. X equals 12. Since I'm in quadrant 1, make sure my x value is 12. I got everything I need. I have y equals 5, x equal 12, r equal 13. All that's left to do is put my ratios together. Already did sine. What do I know? Y over r, 5 over 13. My cosine is 12 over 13. My tangent is 5 over 12, y over x. My secant is 13 over 12. My cotangent is 12 over 5. And there we are. So this concludes part 1 of section 5.3. Please get to know this bow tie diagram. Understand what is happening in it. Go back, watch this video one more time. Understand how we built this thing, where these relationships came from. Translate that right into what you get in your notes packet. It's the same thing. What you saw in the bow tie diagram is just a more complex version of this. I put everything into one picture for you. The book only gives you what? One little example, one angle. Angles have partners in the other quadrants that share these same ratios. The only difference is maybe you have to put a negative sign in front of some of these ratios depending on where your terminal point is located in. Know your Pythagorean theorem. Know how to set things up positionally. Remember, you're all students take calculus. Why? Because that's going to make sure that in these types of problems, you put your triangle in the right quadrant, the correct quadrant, and then solve through appropriately using the same techniques above. Good luck. See me with any questions. Don't feel afraid to watch this video more than once.